Hello everybody. Let me touch upon one more important in-loop testing called processor in-loop testing. Now, just to tell you the actual order in which this processor in-loop testing happens, this usually comes between software in-loop testing and hardware in-loop testing. But many OEMs bypass this particular testing and directly jump from software in-loop testing to hardware in-loop testing because they feel that this processor in-loop testing is redundant, but it has its own advantages. But some tier 1 companies also use in processor in loop testing, and as I'll explain you why it might be redundant, why this might be unnecessary if you are doing good SIL and hill testing. Okay, here we go. What is processor in loop testing? Processor in loop testing is a technique used to test embedded software on processor before it is used on the vehicle. It is popular verification technique for model based design. Now, before the actual processor is going into ECU, the embedded software is embedded into the processor. And processor in loop simulation cross compiles generated source code and downloads and runs object code on your target hardware. Now, processor in loop testing refers to testing and validation of embedded software on the processor that will be later used in electronic control unit. I am sure everybody knows the difference between processor and electronic control unit. So processor is the integral part of the electronic control unit. First, sometimes we test the code exclusive on processor without loading it in electronic control unit. And the algorithms and functions are usually developed on a PC within a development environment, either directly in C++ or model based. Okay, code is usually generated, code is usually developed, and then it is embedded onto the processor. And the code is developed either manually in C++ or model based. That's it doesn't matter actually. And this could be, for example, and model can be based developed in Simulink or Target Link, depending upon model based loop testing tools, which I already covered. And the resulting C++ code must be compiled with a special target compiler for the processor, which is later used in the ECU in the vehicle. Okay, now processor tests. I hope you are all following what I'm saying with a very keen eye. Please be all ears because this is very important. The control algorithms for pill test, processor in loop test, are usually executed on a so-called evaluation board. Sometimes pill tests are also executed on real ECU. Okay, now you understand why pill test is sometimes redundant, because processor anyway goes into ECU and ECU is anyway tested with hill. So this pill test is sometimes considered redundant. Now both variants use the real processor used in controller and not on the PC, as in software in loop testing. Using the target processor has an advantage that compiler errors can be detected. So this has its own advantage. It's not that it is totally useless. So sometimes using the target processor has an advantage that compiler errors can be detected. That's the only advantage as far as many tier 1 companies, automotive tier 1 companies see. And how does it work? Algorithms and functions are developed on a PC. Now this is something which I already explained. The code is compiled using a special compiler for processor. Again, as I explained, the compiler code is downloaded and run on the target hardware. And what is the target hardware here? The processor. This target hardware, which I am talking here, is the processor. Now, the results of normal and PL simulators are compared. Now, how are they compared? Because this normal is considered to be the benchmark results, and pill simulation are the one which we got out of this particular testing just now. Now, benefits of pill: detects compile errors, exposes problem with execution in embedded environment, and collects code coverage on execution time metrics. Now, what is the typical workflow? What is the typical chronological workflow? Model development: create the control system model in model tool like Simulink. Now, this is something which I already covered several times. So, first of all, the model is developed in a MATLAB or a Simulink kind of tool, and with the help of the model, C++ code is generated, and then this code is run the code on the simulated environment, interacting with the planned model to verify its behavior. Okay, now you understand how closely this is to hill. Here also the generated code on a simulated environment. In hill also it is generated code on a ECU in simulated environment. Here it is generated code on a processor in simulated environment. That's the only difference. Next is debugging analysis. Use debugging tools to analyze the code execution on the simulated processor. Okay. Now finally you debug. That is given. Now what are the main popular PIL tools? MATLAB Simulink with embedded coder, a widely used model-based design environment that allows code generation and PIL simulation for various target processors. Okay, and next is Green Hills Multi IDE, Integrated Development Environment. IDE stands for. Okay, an integrated development environment that can be used in conjunction with Simulink for PIL testing, offering features like instruction set simulators and debugging capabilities. And last is vector tool. I'm sure everybody heard of this company called Vector Informatic. They have a lot of tools for in-house testing, lab testing, and this is also a tool, vector tool for uh, provides suitable tools for embedded software development, including pill capabilities for testing automotive control systems. Now, the benefits. I hope you don't find benefits too monotonous, but as a trainer, I feel it is important to understand the benefits of each and every in-loop testing. So process in-loop testing, like other in-loop testing, has early detection, identify issues related to hardware compatibility, compiler optimization, and memory constraints early in the development of the process. This word is important. You are identifying the issues early in the development process. Next is improved code quality. Validate that the generated code functions as intended on the target processor. Reduced hardware costs. Perform testing without requiring full physical hardware setup in early stages. Okay, reduced hardware costs. This is also very important because we are directly uploading the software in the compiler, of course in a simulated environment, so naturally this will reduce the cost. Okay, so this is processor in loop, but I reiterate, this processor in loop is mostly considered or perceived as redundant testing. Most of the tier 1 companies are directly jumping from software in loop to hardware in loop, but it is good to know what this processor in loop is. Okay, so with this I am concluding this in loop testing session. Okay, I have covered all the various types of in-loop testings. I hope all of you got a comprehensive idea about the various types of in-loop testings. Okay, thank you.